All right, now back here in Moog Modular V, what I want to do actually before we go on a little bit further here is just show you what happens when we have some higher clock rates here. Now, as we saw before with the lower clock rates, if I take this down and I play our sampled waveform out, we're getting almost a random sample of that sawtooth wave. And essentially, what we want to know here is the fact that if we sample at a higher rate, we get a more accurate representation of the waveform that we are sampling. So if I increase the frequency of this, say up to now 9 hertz or so, now you see again on our diagram here, what we have is a staircase wave that really looks a lot more like the sawtooth than it did at the lower frequencies. And if in fact we increase this up significantly, now we're up in the 40 hertz range there. You hear a little bit of a click or a little bit of fuzz in there from the sawtooth, the actual sampling of the sawtooth itself. But in fact, that shape of the descending waveform there, the descending control voltage, is very close to the original sawtooth itself. And that's really because the steps are so close together that we're really having a hard time hearing them individually. And the implication of that in terms of the digital world is that a higher sample rate when you're digitizing stuff gives you a more accurate representation of the thing that you're sampling, which is why we're trying to always sample at higher and higher sample rates for higher and higher audio quality in the digital world. And this is really a kind of an illustration of that. Let's crank this way up. So there you can't even really hear the steps anymore. It really looks and sounds very much like a standard sawtooth wave. Again, if we take this way back down again, more into the sub-audio range, there you can very clearly hear the steps. So that in and of itself is kind of fun, and we can do some interesting things with that musically. But as I mentioned before, because we don't really have any synchronization between the sawtooth and the sample itself, it's hard to predict exactly what those pitches are going to be that are coming out of there in those steps. And the other thing to understand is that the sample and hold in and of itself has no relationship to the normal tempered scale, the normal musical scale that we're familiar with. And so those pitches that are coming out of there are really not at all related to scale steps. They're not related to musical pitches directly, at least. So we can use those, of course, as a sound effect, or we can use that as a sound source in any kind of more abstract music environment. But we're not really going to be able to use this as an arpeggiator as such, the way you're familiar with the arpeggiator on digital keyboards, where you just hold down a bunch of notes and it will arpeggiate those notes in all different kinds of patterns. The sample and hold isn't really appropriate to try to use as an arpeggiator, at least this kind of analog sample and hold. Now, before we move on again, I just want to show you one other aspect of this here, which is the glide function. In the next video, we'll just take a quick look at that glide and show you what it does.